Class, this is the first video on section 6.2, integration by substitution in your note packet. Section 6.2 begins on page 77 in your note packet. Before we get started on this, I want to just take a moment to do a review of section 6.1 and give you sort of a big picture of what section 6.2 is all about. So back in section 6.1, we learned 7 rules of basic anti-differentiation. And I just want to go over those real quickly. The antiderivative of a constant with respect to x is just equal to the constant times x plus c. Now, how do we know that we got the right antiderivative? You differentiate the antiderivative, and you better end up with what's inside the integrand in the indefinite integral. So derivative of 12x is 12, and the derivative of a constant, you know, is always 0. So the derivative of 12x plus c is just 12. Then we had the power rule of antidifferentiation. The antiderivative of x squared, you add 1 to the exponent and then divide by the new exponent. And so when we add 1 to the exponent, we get 3, and then we divide by 3, and then we add the arbitrary constant c. And then this simplifies to 1/3 times x cubed plus c. So the antiderivative of x squared is 1/3 times x cubed plus c. And if you differentiate this with respect to x, you end up with x squared. The antiderivative of a constant multiple times the function, right? Antiderivative of 5x squared. In this situation, right, we just carry the multiplicative constant 5 along, and the antiderivative of x squared is x cubed over 3, and then that simplifies to 5/3 times x cubed plus the arbitrary constant c. In the next rule, we have a sum and difference of terms, and when you're finding the antiderivative of a function that consists of sum and difference of terms, you can find the antiderivative term by term. So the antiderivative of x cubed is 1/4 times x to the 4th. The antiderivative of 4x is 2x squared. The antiderivative of -7 is -7x. And then when we're all done antidifferentiating, we add the arbitrary constant c. In the 5th rule, we had the antiderivative of e to the x with respect to x. And the antiderivative of e to the x is just e to the x plus the arbitrary constant c. And then in the 6th rule, we have the antiderivative of 1 over x with respect to x. And the antiderivative of 1 over x with respect to x is equal to the natural log of the absolute value of x plus c. And then the last and 7th rule we learned in section 6.1, the antiderivative of an exponential function with a base different from e. In this case, we're taking the antiderivative of 2 to the x with respect to x. That antiderivative is equal to 1 over the natural log of 2 times 2 to the x plus c. So that's sort of a quick overview of the 7 rules of antidifferentiation that we learned in section 6.1. Now I want to give you a quick overview of what section 6.2 is all about. And that is a continuation, 6.2 is a continuation of antidifferentiation, but we're going to be antidifferentiating some functions where we have to do a substitution method with. So let's just review here real quickly. If I have a function f of x equals x to the 5th, you know how to differentiate that function. The derivative f prime of x is equal to 5 times x to the 4th, right? Bring the 5 down front, subtract 1 from the exponent. But remember, anti-differentiation is going in reverse. And so if the derivative of x to the 5th is 5 times x to the 4th, then it has to be true that the antiderivative of 5 times x to the 4th is equal to x to the 5th plus the unknown constant c. Right? We need more information before we can figure out what that constant c is equal to. The derivative of x to the 5th is 5x to the 4th, and the derivative of a constant is always 0. Now let's change the function and replace the x in x to the 5th with an algebraic expression involving x. You know when that happens, you have to use the chain rule for the power function in finding the derivative of that function. So here we have g of x is equal to x squared plus x minus 1 to the 5th power. So to find the derivative g of x, g prime of x, right, we bring the exponent 5 down front of the left parentheses, subtract 1 from the exponent, just like we did up here with f prime of x. But then you know we got to multiply that by the derivative of what's inside the parentheses. And the derivative of x squared is 2x, the derivative plus x is plus 1, and the derivative of the constant minus 1 is 0. So the derivative of g of x is equal to 5 times this in parentheses raised to the 4th power times the derivative of what's inside the parentheses, 2x plus 1, by the chain rule. So if the derivative of g of x is equal to this, then the antiderivative of this has to equal g of x up here plus c. And that's what we see down here. We have the antiderivative of 5 times x squared plus x minus 1 to the 4th times 2x plus 1. That's g prime of x. That antiderivative is equal to g of x, x squared plus x minus 1 to the 5th, plus an unknown constant c, because you know the derivative of a constant is always 0. We need more information before we know what the exact value of c is. Well, it's not obvious that this antiderivative is equal to x squared plus x minus 1 to the 5th plus c. In this section 6.2, we're going to learn how to find the antiderivative of functions like this.